Hey guys, today we're doing our last section for chapter 2.4, which is all about modeling with quadratics. So basically all of our word problems for quadratics, how we handle those, how we write our equations. For 2.4, we're going to be given our information in three different ways. We've got three different strategies that we're going to focus on for today. And those three strategies are based on what information we're given. So in box 1 here, I just kind of laid out the strategies for you guys, so you guys can have a nice little summary of if we're given this information, this is the method we're going to be using, and you got that for all three of those. So in boxes 2, 3, and 4, then, we're going to do an example of each of these three different strategies. So given a point and the vertex, we're going to use vertex form for that. Obviously, if we've got our vertex and then some other point, we can figure out really easily what that a value is. If we're given our x-intercepts and a point, well, obviously we're going to use vertex form, or sorry, our intercepts form for that. And then if we're given 3 points, so there are not any points in particular, but it's not one of my 2 x-intercepts, it's not my vertex, it's just 3 random points. We're going to be using actually a 3-variable system to solve for what that is. And with that, we're also going to use standard form, y equals ax squared plus bx plus c. So just something to be prepared for. All right, so let's go ahead and hop on in. Box 2 here, we have the graph that's given to us, and the description tells us that a meteorologist creates a parabola to predict the temperature tomorrow, where x is the number of hours after midnight and y is the temperature in degrees Celsius. Write a function f that models the temperature over time. What is the coldest temperature? So I got 2 questions here. First, we have to write the equation, and then second, the coldest temperature obviously would be this point right here at my vertex for the coldest temperature. That's the lowest point. So with the information that we're given, we are told these 2 points right here. I'm going to use a different color so you can actually see them. We've got 4, 0 and 24, 0. Those are our 2 x-intercepts. So that would be my p and q value. If I'm looking at my intercepts, so p doesn't really matter which one is which, but p I'm going to say is 4, q is 24. And then we have some other random point, 0, 9.6, which actually, it's a special point. It's my y-intercept, right? That's 0, 9.6. But in this case, our y-intercept, because of the equation that we're using, isn't really useful to us as a y-intercept. But just in general, again, for our other point, which would be an x and y value, when x was 0, my y was 9.6. So I'm going to use those 3 pieces of information in my equation to be able to write my equation. So I know in general y equals a x minus p times x minus q. That's intercepts form. So if I plug in the things that I know y was 9.6. I don't know what a is. That's what I'm going to be solving for, which really is the case for most of these problems. You're going to be given information. You need to figure out what that a value is. X we said was 0, minus 4, 0, minus 24. And we've got that equation. So now we just have to go through and solve for a. So 9.6 equals a times negative 4 times negative 24. So 9.6 equals a, let's just rewrite it this way. Negative 4 times negative 24 is positive 96. So 96a. Divide both sides by 96, and we get a equals 0.1. 0.1 if you want to be more precise with it. So then, to be able to write our equation, let's just do it off to the side over here. Let's do it in red. So in our equation, we now know that a is 0.1, x minus 4, x minus 24. That would be our equation for that function. Now, you don't have to combine it. You don't have to put it in standard form or anything like that. As long as it's written in one of our 3 different forms, I'm okay with it being left that way. For the second part, for what is the coldest temperature, so we need to find the vertex of that equation. So in this case, I've got, in vertex form, remember, in intercepts form, our vertex is always halfway between those 2. So we got 1, 2, 3, 4, 5, 6, 7. Yeah, I'm right about here. which halfway between 4 and 24, right? Remember how we do that? So in this case, 14 is halfway between those two, right? There's 20 spaces in between. 10 would be halfway. This x value is 14. So then to find my vertex, I'm just going to plug 14 for my x value into my equation. So y equals 0.1 times 14 minus 4 times 14 minus 24. That gives me 0.1 times 10 times negative 10. So y equals negative 10. Because 10 times negative 10 would be negative 100. Negative 100 times 0.1 is negative 10. So in this case, negative 10 degrees Celsius is the coldest temperature. All right, for box 3. Box 3, now we're going to point and vertex. So in this case, we're given a human cannonball. So the graph shows the parabolic path of a performer who is shot out of a cannon, where y is the height in feet and x is the horizontal distance traveled in feet. Write an equation of the parabola for the performer. Equation for the parabola. The performer lands in a net 90 feet from the cannon. What is the height of that net? So once again, start with our equation. Now, because we're given the vertex in this case and some other point, we're going to be using our vertex form, which that is y equals a x minus h squared plus k, where h and k are my coordinates for my vertex. So in this case, the information that I'm given, I know that for my, I'm just going to write over here, h and k are 50 and 35 respectively. And then just some other point x and y would be 0, 15. So 0 is x, y is 15. And then I'm going to go ahead and just jump to plugging that in. So my y, 15, I don't know what a is, x is 0, minus an h of 50, plus a k of 35. And I'm just going to go through and solve that equation. 15 equals negative 50 squared is 2500 plus 35. So then minus 35 is a negative 20 equals 2500a. I divide by 2500 on both sides. And I get that a is negative 0.008. So that means my equation for this one, I'm going to write this in, we'll keep it in blue, we'll put it over here in the corner, would be y equals negative 0.008 parenthesis x minus 50 squared plus 35. So now, if I was trying to figure out the second part of this problem, to get 90 feet from the cannon, that's my x value, right? 90 feet from the cannon. I'm trying to figure out what the y value is. That'd be the height of my cannon, or my performer at 90 feet away. So I'm just going to go ahead and plug that into my equation. Plug in 90 for our x value. So y equals negative 0.008 times 90 minus 50 squared plus 35. So we've got y equals negative 0.008 times 40 squared plus 35. So then I'm going to go ahead and do 40 squared, which is 1600. Negative 0.008 times 1600 plus 35. So times negative 0.008. This gives me a negative 12.8 plus 35. Gives me 22.2. So, I don't know. Okay, sure. Feet over here. 22.2 feet up in the air is where that net would be. Or where that net would have to be if we wanted to make sure that the guy or girl that got shot out of the cannon landed safely in the net. All right, so for box 4, for our very last one, for this one, we are working with a lot of information. So in this one, we've got we're given that NASA can create a weightless environment by flying a plane in parabolic paths. So kind of going up, reaching the peak, and during that peak, it kind of creates this weightless environment. The table shows h, which is height in feet, and the plane, of the plane, t seconds after starting the flight. After about 20.8 seconds, the passengers begin to experience a weightless environment. Write and evaluate a function to approximate the height at which this occurs. So again, write our equation first, and then we're going to be using that to figure out what height we're at 20.8 seconds. Because we can see it's going to be around 30,000 feet. We can see that at 20 seconds, we're at 30,600 feet. So we're just going to have to try and figure out the height just past that. So in order to do that, since we're given 3 points, again, if we look back at our strategies, we're going to have to use our standard form of our equation. So ax squared plus bx plus c. And we don't know, like, these aren't special points. We don't know any of these are if any of these are our vertex or anything like that. In this case, we can see that my numbers just keep going up, so it doesn't look like, actually, it looks like we can probably figure out that our peak is right between 30 and 35 seconds, because we go from 32,000 feet back down to 32,025 feet. So we can see it happens somewhere between those 2 points, or maybe right before 25 seconds, maybe. But we don't know exactly what the vertex is, and really the important thing is that none of these are told, like, we're not told that any of these are special points. So we have to rely on just what we do know. So what we're going to have to do, we're going to pick out 3 different points and plug those into 3 different equations for x and y to be able to write a 3-variable equation so we can solve for what a is, what b is, and what c is. So I want to be very strategic in the points that I choose, because some of them might be easier to use than others. I'm going to try and pick as clean of numbers as I can based on, the table that I'm given. So looking at my numbers here, I need 3 points. So I need 3 x and y's, or in this case, t and h's, to plug into our equation. So I'm going to try and choose the nicest ones possible. And just the numbers that look the cleanest to me are 10, 26,900, 20, 30,600, and 30, 32,100. So those ones are as clean as possible. So what I'm going to do then is take each of those x and y values, in this case, again, h and t values, and plug those into the standard form for our equation to get a 3-variable system set up. So I'm going to go ahead and do that and then jump in a little bit. All right, so as you can see, I've gone ahead and done that substitution real quick, where this top equation, I'm just plugging in 10 for x and 26,900 for y, and so on and so forth. So 20, 30,600, and then 30, 32,100. Just doing that substitution in there for a's and for x's and y's. So what I have to do next is just go ahead and simplify those. So I'm just going to go ahead and just square my 10, 20, and 30, and then kind of just rearrange a little bit. So here I end up with 26,000 equals 100 not a squared, just 2,600, or sorry, 100a plus 10b plus c. Here we've got 30,600 equals 400a plus 20b plus c, and then 32,100 equals 900a plus 30b plus c. And again, that's just from squaring 10, squaring 20, squaring 30, and then just rearranging it so it looks a little more simple. So from here, I have I have a 3-variable system, right? I've got a, b, and c. I've got 3 equations. I can go ahead and solve that. Now, going back to what we did last chapter and to 1.5, I think is when we did 3-variable systems. We've got our 2 different options on how we can do that. We can either use elimination or substitution, which here, either one would work. Whether you want to do elimination with your c values here, because those are going to be pretty easy to get rid of since they're all just c already. Or you could always take one of the 3 equations, solve for c, and then substitute that in the other 2 to get it down to a 2-variable system. But again, that's our goal. We want to make sure that we get it down to just a 2-variable system so that we can solve that 2-variable system using Algebra 1 skills. Just personal preference for me, I would prefer to do elimination. So what I'm going to do is choose one of my three equations to be my eliminator, and I'm going to take that equation and pair it up with my other two to get rid of my C values. So in this case, I'm just going to choose the smallest numbers to be my eliminator. So that top equation I'm just going to use as my elimination equation. And again, to do that, I want to make sure that when I add my two equations together, my C cancels out. So right now they're all positive C. So I'm just going to multiply this top equation by a -1 in order to get that to be a negative C. So when I add them together, my C's cancel out. So that means negative 26,900 equals negative 100A minus 10B minus C is going to be my equation I'm pairing up with the other two. So then I'm going to go ahead and just do that. We can go right here. So my middle one, 30, let's just do that. 30,600 equals 400A plus 20B plus C. And I'm pairing that up with negative 26,900. I don't know why I keep throwing those zeros in there, or those commas. 26,000. Did I copy it down wrong? I did. All throughout here, it's supposed to be 900s. Sorry, people. This is 26,900. Glad I caught that now. 26,900. So again here, 26,900 equals negative 100A minus 10B minus C. So as I do that, if I just go ahead and add going down, my C's are going to cancel out. This leaves me with 3,700, because I just did 30,600 minus 26,900. 3,700 is what I'm left with. 300A plus 10B. So that's equation number one. So I've got now a two-variable system, or two-variable equation. I'm going to do the same thing with my bottom equation. So 32,100 equals 900A plus 30B plus C. And once again, I'm going to pair that up with 26,900 equals negative 100A minus 10B minus C. And as I add up going down, I end up with 5,200 equals 800A plus 20B, and my C's canceled out. So now I've got two variable equations. I've got 3,700 equals 300A plus 10B, 5,200 equals 800A plus 20B. So I'm going to go ahead and pair those two equations up and combine them together. So let's just do that in green now for this step. So 5,200 equals 800A plus 20B. 3,700 equals, 300A plus 10B. So again, I can now go back to elimination if I want to, or I could go to substitution to solve this two-variable system. For this one, again, it's not set up nicely for substitution, but it is set up okay for elimination. If I wanted to do elimination here, I would probably want to eliminate my B value, which again, I wanted my numbers to be the same, but one positive, one negative. So if I multiply this bottom equation by a -2, that's going to make my B value -20, which is what I'm going for. So here, if I do that, 5,200 equals 800A plus 20B. This gives me -7,400 equals -600A minus 20B. So adding up, going down, my B's cancel out. I end up with -2,200 equals 200A. So divide by 200 on both sides, and we get that A is -11. All right, so -11 is my A value. Now I'm just going to start working my way back up the chain to solve for B and then to solve for C. So if I go to one of the two equations right above for my two-variable system to solve for my B value, I'm going to choose the simpler one, and let's go back to, I don't know, we can use this kind of yellow here. Hopefully it shows up okay on video. So if I take my A value, oh, that's a thick boy there. Let's skinny you down a little bit. There we go. So we got our A value. We want to plug that, ooh no, A value. We want to plug this in for A right here. I'm going to use the 3700 equals 300A plus 10B. It's the simplest one we have. So if we did that, 3700 equals 300 times negative 11 plus 10B. That's 3700 equals negative 3300 plus 10B. So I add 3300 on both sides. I get 7000 equals 10B. So I divide by 10 on both sides, and we get that B is 70. Sorry, 700. All right, so we've got our B, we've got our A, we just need to find C. So when I do that, I'm going to go all the way back up to my original eliminator, because that's the simplest one we have. Let's do this, but let's change it to, sure, let's do pink. We don't use pink enough. We all could use more pink in our lives, right? So 26,900 equals 100 times negative 11 plus 10 times 700 plus C is the equation I'm trying to solve. And I'm going to go ahead and scooch you back over a little bit so you're actually on the page. Mostly, kind of, ish. Sure. All right, so that is 26,900 equals negative 1100 plus 7,000. So 26,900 equals 5,900 plus C. So minus 5,900 on both sides. And we get 21,000 for C. So that means our equation, if we go back to black here, our equation for our, so that means our equation, if we go back to standard form, y equals negative 11x squared plus 700x plus 21,000 is our final equation. Actually, nope. I made a mistake here. We want to use our variables that we were given. So here, h equals 11t squared plus 700t plus 21,000. But same equation, just making sure we use our variables appropriately. So the height is negative 11 squared, negative 11t squared plus 700t plus 21,000. Now that would be our equation. That's most of the work. Here, what they want us to do is find our height at, or our altitude at 20.8 seconds. So all we have to do for that, I'm going to use a different color. Let's pick a color. Let's do something, oh, some sparkle stuff? Let's do some galaxy. And there we go. All right. So for that, we're just going to plug in 20.8 into our equation. So h equals negative 11 times 20.8 squared plus 700 times 20.8 plus 21,000. So I'm going to go ahead and grab my calculator real quick. 20.8 squared times negative 11 is negative 4759.04. 700 times 20.8 is 14,560 plus 21,000 minus my 4759.04. In total, we get 30,800.04 20.96 feet. That is the height at 20.8 seconds, where we start experiencing weightlessness. So that's all I got for you for 2.4. Homework is down there at the bottom, page 80 and 81, 4 through 24, every other even. So I do realize some of these are going to take a while, so that's why we're doing every other even. So basically, all of my multiples of 4. 4, 8, 12, 16, 20, and 24. As always, if you have any questions, concerns, thoughts, or ideas, make sure you guys are reaching out and letting me know. Otherwise, have a fantastic day, and I'll see you tomorrow.